Okay, so I'm going to assume you had a go at this problem, so let's go through the solution. I want to identify the language of this DFA. So if you've got no idea where to start, a good tactic is just to try some strings and see if you can spot a pattern. So I guess I'll try the strings, empty string 0, 1, 1, 0, 0, 1, 1, 1, 0, 0, and I'll see where we go from there. So if I start in S0 and I read nothing, I stay in S0, so that's rejected. If I start in S0 and I read a 0, then I go to S1, then I stop, so that's accepted. Read a 1, that's rejected. 1, 0, accepted. 0, 1, rejected. 1, 1, rejected. 0, 0, accepted. So now I want to see if there's some sort of pattern among these strings that we can identify. So it looks like every possible string that's accepted is ending in a 0, and the strings that are not accepted don't end in zeros. So that looks like it'd be a reasonable guess. So you can sort of see that from the behavior of the DFA, right? Because if ever there's a 0, it goes to the accepting state. You can read as many zeros as you want, and then if you finish there, you'll accept. But if there's a 1, you go back to the rejecting state until you see a 0 again. So we conjecture that we'll call this DFA A. The language of A is any binary string W, so W in set containing 0, 1 star, such that W ends in a 0. Okay? If you want to, so writing it just like that in plain English is perfectly adequate. If you wish, you can write it a little bit more formally. You could write W is an element of 0, 1 star, and there exists some string alpha, so there exists an alpha in 0, 1 star, such that W is equal to alpha 0. So that is, W can be written as some string alpha followed by 0. Either one of these are perfectly adequate. This one here will get you all the marks. There's no reason why you can't use plain English sometimes to describe a language. Now we've just guessed this, right? We could be wrong. Later on we're going to show how you can formally prove that this is the language, okay? But for a moment we just want to identify the language, and we're going to guess it's this, which it looks like it is, right? Okay? What was the second problem I gave? The second problem I gave was construct a DFA. Construct a DFA that recognizes the language L. That recognizes L. What was L? L was any binary string that starts with a 1, ends in a 1, and has at least 1 0 in between. So W is equal to 1, 0 to the n, 1, where n is strictly greater than 0. So 1, 0, 1, or 1, 0, 0, 1, or 1, 0, 0, 0, 1, and so on and so forth. Okay? So how can we construct such a DFA? Well, we'll start with a start state, so S0. Now, if the empty string is accepted, that means the initial state has to be an accepting state. And the empty string is rejected, so that means S0 is not accepting. Now, if the first character I read is a 0, then it doesn't matter what else I read. I know the string has to be rejected because it has to start with a 1. So I can put a transition here. If I read a 0, I go into this trap state where I'll always be rejected. So this is like a bin where if you go to the bin, you stay in the bin forever. So if I read a 0, I know it definitely won't satisfy this pattern. So you go to the bin, and once you're in the bin, you stay in the bin forever. So once you move to T, anything else you read, you stay in T. If I read a 1, I'm going to go to this new state. And this state sort of is the DFA's state representing the fact that I've read a 1 so far. So this state here represents the I've seen a 1 so far. And so what next? Well, if it starts with a 1, it has to be followed by at least a 0. So if it's not followed by 0, i.e. if it's followed by a 1, you go straight to the bin. And if it's just a 1 by itself, then you'll be rejected. So this is not an accepting state. So 1, 0. So if I see a 1 and then I see a 0, I'll make some new state, S2. And this represents I've seen a 1, 0 so far. I'm still not going to accept because I have to have a 1 on the end. I can freely consume any more zeros and go back to this state because any number of zeros in the middle, as long as there's one of them, is permitted. So 1, 0 read as many zeros as I want, and then I need to read the 1 on the end. So if it's followed by a 1 on the end, then I can go to the accepting state. S3. There we go. So 1, 0, 0, 0, 0, 0, 0, 0, 0, 1. And then if it's followed by anything more, then I should reject it because it won't match this pattern. So for example, the string 1, 0, 0, 0, 1 should be rejected. So from S3, if there's anything more after that last one, I should go to the bin. There we go. It's maybe not the most efficient DFA, but it's certainly a valid solution. Again, we can formally prove later on that this DFA really does recognize this language. But again, all we're concerned about now is constructing languages from DFAs and constructing DFAs from languages. So these are the two answers to the problem I asked before.